Let's take a look now at example number 7, which is again going to be a fairly complicated looking limit that will have a very similar approach to the limits we've seen in this section. We'll start off by seeing here that we have something kind of, well, messy going on here. Notice that if I wanted to, I could attempt to try to evaluate this limit directly, but I'll find that it'll ultimately fail. Here's why. Notice if I wanted to, I could start by thinking about the limit of this first term that I have here. And since I want to do the limit of the square root, I could think about doing the limit of the inside. Now, underneath this square root, I have a polynomial, and so I know that only the first term is going to matter. So what I'm going to have here is x to the sixth, as x is a number that's becoming infinitely large. Overall, this whole first term is going to be moving towards infinite. Now, when I look at the second term, that's also going to be moving towards infinite. And I'm going to have something like infinity minus infinity. Now, very strangely, this is again, this value here is not a well-defined mathematical value. And so, we cannot stop here. It would be very, very wrong to just state something like, oh, okay, this is going to clearly be something like the value of 0. That is not going to be true. So let's go ahead and actually take a look at what we can do to correctly compute this. All right, I'm going to start by following the hint and attempting to multiply by 1 in the form of the conjugate. All right, so I'm going to go ahead and take my limit, which had the shape x to the 6th plus 5x to the 3rd minus x to the 3rd. And I'm actually going to divide by 1, just so it looks like it's in a fraction form already. And that way, when I multiply by the conjugate, which is going to be my square root of x to the 6th plus 5x to the 3rd plus x to the 3rd, and x to the 6th plus 5x to the 3rd plus x to the 3rd, I'm ready to go. So when I go ahead and I attempt then to multiply these together, I can use this conjugate to make the numerator simplify out really, really nicely. So remember here that what I really am going to have is something that looks like a difference of squares that's been factored. And so when I multiply it back out, I can just take the first item squared minus the second item squared. So that's going to give me something like x to the 6th plus 5x to the 3rd. That's what I get when I square the square root. And then I'm going to have minus x to the 3rd squared, or x to the 3rd times an x to the 3rd, which is again an x to the 6th. In the denominator, I'm still going to have that square root and my plus x to the 3rd. So if I simplify this up a little bit more, I'll notice that, again, what I have is only a 5x to the 3rd in the numerator, because the x to the 6th have canceled out. All right, so let's see now where we're at and if things have gotten any better. Okay, so we used to have this kind of infinity minus infinity, which we couldn't do anything with. And now, oh boy, if we look at the top is kind of moving towards infinitely large, but then so is the bottom. So we're still stuck, and we got to try something else. So here's what I'm going to try now. You can kind of see that we're back to this fraction form that we were at previously. And so I'm going to go ahead and choose to multiply again by another fancy red thing. And this time, I'm going to actually choose 1 over x to the 3rd, kind of following our idea that I want to multiply by 1 over x to the largest power that I see in the denominator. Now, the only thing to be aware of here is that sometimes people will pick instead x to the 6th. And the reason I'm not doing that here is because x to the 6th is under a square root. And so that technically chops its power in half, roughly. So that's why I'm going with x to the power of 3. So if I was to go ahead and do this, I can see that what I'm going to end up with now is a limit as x approaches infinity. And in the numerator, I'm going to simplify down to just the number 5. In the denominator, I'm going to end up with an x to the 6th plus a 5x in the radical. That's going to be divided by x to the 3rd, so that's kind of crappy. But then I just get a plus 1. So again, you can see what we're doing here is we're just constantly kind of shifting around where the problem occurs. Here I started with infinity minus infinity. Now I had infinity over infinity. And now I kind of have infinity over infinity, but pushed into a tiny bottom left corner of this fraction. And so much like what we did in the last example, we're going to go ahead and think about what we might be able to replace x to the third with. We'd like to be able to replace it with the square root of something. But we have to make some observations. First, we can say, since x is moving towards positive infinity, then we can assume that x is going to be a number that's greater than 0. And so, x to the third power could actually be the same as here, the square root of x to the power of 6. Now, you might have to spend some time to think through why exactly that's true, but again, we actually would have the same principle in play here. In general, the square root of x to the 6th should be the absolute value of x to the third. But since I know that x is positive, I have no need for the absolute value bars over here, and so I can just get rid of them. And this allows me to make a really, really nice replacement. So once I replace that, I can see that I'm going to have square root of x to the 6th plus 5x over the square root of x to the 6th, still plus a 1. And now I can simplify this down. I can combine everything there into one square root and then split my fraction. And I'm actually going to try to do that here in one step to save on space. So notice when the fraction is split, I would get x to the 6th over x to the 6th, which is 1, and then 5x over x to the 6th, which is really going to be 5 over x to the 5th when I reduce. So now I'm going to be left with this, and I can easily now do the limit. Watch. The limit of the top is 5. The limit of the square root, well, I can do the limit of the inside first. The limit of the inside is going to be 1 plus, well, this piece is going to be moving towards 0, because 5 over something getting infinitely large is getting close to 0. And then I get plus 1. So this is going to be 5 over 1 plus 1, or a grand total result of 5 over 2. Hopefully you can see here that two things. One is that I could not have said then at the beginning that infinity minus infinity results in 0. It doesn't. And this time it results in 5 halves. How weird is that? But the other thing that I have to be careful with here is the complexity of a problem like this. Now, these problems are doable, but they'll take practice. And so you can probably guess the advice that's coming. It's going to be really important for you to go to the worksheets associated with these sections and practice, practice, practice. Really make sure that you understand these ideas. And of course, also ask me as many questions as you need to make sure that you understand the concepts very, very well. Now, example number 8 is actually going to be an example that I'm going to leave for you to try to practice on your own. And there are some interesting ideas here that you can try to work through. Try this out before you even go to take a look at the worksheets to make sure that you understand everything that's located in this example. And don't forget that all of the notes associated with this section are going to be located in the Blackboard calendar underneath the lecture notes for this specific section.